Hello friends, in today's session we will see some new classes, new topics related to Applet class chapter. Okay, so this is the third theory part, I guess. We will start now. Applet initialization and termination. So which methods we will use to handle the overall applet, we will see. We have to understand the order in which the various methods will call. Okay, when an applet begins, following methods are called in this sequence: init, start, paint. And when an applet is terminated, first of all stop is called and then destroy will be called. Okay, so we will see one by one all these methods. First is init method. The init method is the first method to be called. Okay, and it is used to initialize variables. So that you should initialize all the variables required in this init method itself. And this method is called only once. Very important line, only once during the runtime of your applet. Overall running, in your overall runtime, this is the only method and it is the only once called during the runtime. Second is the start method. It's called after the init method. It is also called to restart an applet after it has been stopped. Okay, so init will be called only once. Start can be called again to restart the applet. Init is called once the first time applet is loaded. Start is called each time applet's HTML documents is displayed on screen. Okay, so every time start will start the applet. So if a user leaves a web page and comes back, again the start will be called. Third is paint. Paint is called each time your applet's output must be redrawn. Okay, so likewise in the previous session I explained you when your applet window is minimized and it is went to background, and again after some time it comes to foreground, that each and every time the paint should be called. This situation can occur for several reasons, like the window the window in which the applet is running may be overwritten by another window and then uncovered. Okay, or the applet window may be minimized and then restored. Likewise, I have explained you. Paint is called only when paint is also called when the applet begins the execution first time. Okay, so no matter if the applet window is overwritten or not, paint will be called minimum once. Okay, whatever the cause, whenever the applet must redraw its output, paint will be called. Paint method has one parameter that is called as graphics object. This will contain the graphics context, which describes the graphics environment in which the applet is running. So that you will specify, create a graphic object first, graphics object, and then you will pass that object as a parameter to a paint method. This context is used whenever output to the applet is required. Okay, and it describes the graphics environment in which the applet is running. Fourth stop method is called when the web browser leaves the HTML document containing the applet when it goes to another page, for example. So applet will be stopped automatically. Okay, so when user opens the applet file, applet containing HTML file and leaves that page and go to the second tab and open another page like www.google.com, or in another page amazon.in, or and so on and so on. Okay, so first page in which your applet was running was leaved as it is. So in that case, the applet will be stopped automatically. Okay, applet when stop is called, applet may be probably running state. Okay, you should use stop to suspend threads that do not need to run when the applet is not visible. Okay, so unnecessarily, if it is running in background and you do not require the threads that are running the applet, you should stop the applet by your own. You can restart them when start is called if the user returns to the page. Okay, destroy. The destroy method is called when the environment determines that your applet needs to be removed. come maybe from memory. Okay, so environment determines or environment tells that your applets needs to be removed completely so that it will be destroyed. You should free up any resources the applet may be containing. It can be a PNG file, it can be a MP3 file, or it can be audio clip like this MP3 only. The stop method is always called before destroy. So before destroying, the applet must be stopped. So the stop is always called before destroy. Next, overriding update. In some situations, your applet may need to override another method defined by AWT called app updates. Okay. So instead of these methods we have seen right now, applet will be required, may be required to override another method that is called as update. This method is called when your applet has requested that a portion of its window to be redrawn. Okay. So only portion will be redrawn. The default version of update simply calls the paint method. Okay. But you can override the update method so that it performs more subtle repainting for the particular portion. Overriding update is a specialized technique that is not applicable to all applets, and the examples in this course do not override update. Okay, so it is very specialized technique and it is not applicable to all applets, but you have to remember that it is called if some portion of your applet to be redrawn, and basically it calls the paint method. Some applet display methods we have mentioned. As we have mentioned, applets are displayed in the window, and AWT based applets use the AWT to perform input and output. Although we will examine the methods, procedures and techniques necessary to fully handle the AWT windowed environment. Okay, so we will examine the methods, procedures and techniques necessary to handle the abstract window toolkit environment in a subsequent chapters upcoming. A few are described here because we will use them to write sample applets. Okay, so some methods, procedures and techniques to handle the abstract window toolkit will be seen over here. Okay, and detailed speeding based applets are described later on. As described in the previous chapter, that is chapter 13, to output a string to applet, use drawString method. Okay, so here chapter 13 is maybe your chapter 10 because I have merged the chapters 1 and 2 together. So whenever I am referring to chapter 13, it will be chapter 12. Whenever I am referring to chapter 20, it will be chapter 19. Okay, so you have to take care of which chapter you are referring to. Okay, so it may happen like I am telling you the chapter 21 and you go to 21 you will say that there is nothing you explain in the video, but it is not like that because I have merged the chapter introduction to Java and overview of Java into single chapter. So every chapter number I am mentioning over here in the PPT will be one before the chapter I am actually telling. Like here I am referring to chapter 13, maybe means it is I am referring to chapter 12. Okay, to output a string to applet, use drawString method, which is a member of graphics class. Okay, so it is called from within either update or paint method. Which method? drawString method, and which is a member of graphics class. Following general form: void drawString, string message, integer x, integer y. Okay, how to draw string? First is string message and x and y coordinates. Message string to be displayed beginning at x and y coordinates. Okay, the upper left corner starts with 0 and 0, that is x coordinate 0, y coordinate 0. The drawString method will not recognize new line characters at all. Okay, so if you want to start a line of text on another line or new line, you have to do so manually, specifying the precise xy location at the new line. Here you want to display the output. Okay. And in the upcoming chapters, there are techniques. Those will make this process easy. To set the background color, use set background method. To set the foreground method, use set foreground method. These methods are defined by component class and they have the following forms: set background color, new color; set foreground color, new color. Okay, so you have to specify the color object. and new color specifies the new color object. The class color defines constant shown here so that we can use them directly. Instead of giving the number, you can directly give it as set background like color dot red. Okay, color dot black, color dot blue, color dot cyan, color dot dark gray, color dot magneta, color dot orange, color dot pink, color dot red, color dot gray, color dot green, color dot light gray, color dot white, color dot yellow. So these are the default constants provided by default, okay, inbuilt. So you can use them directly as a parameter as a color object over here in the set background and set foreground. Okay. Next, uppercase versions of constants are also defined. So you can directly place it as color dot green GREEN in a capital letter. Good place to set the foreground and background colors is in the init method. So whenever you will initialize the applet, you will place the background and foreground colors. You can change these colors as and when necessary during the execution. Okay, as many times as you want. You can obtain the current settings for the background and foreground color by calling the get background and get foreground easily, respectively. Get background will give you the color for background and get foreground will give you the color for the foreground. Here is very simple applet that sets the background color to cyan, foreground color to red, and displays a message that illustrates the order in which init, start, and paint methods are called when an applet starts up. Okay, so this is a simple applet. Applet code is sample. It extends applet. Okay. Init will set a background color to cyan and foreground color to red, and message is displayed like inside init. So in start, message is appended with inside start. Okay, inside init dash dash, inside start dash dash, then inside paint full stop, and drawstring message will be displayed. At which location? X coordinate 10, Y coordinate 30. So which message will be displayed? Inside init dash dash, inside start dash dash, inside paint full stop. Okay, inside init, inside start, inside paint. Okay, that is the background color provided, that is cyan color. Okay, this is the black and white output. So I am unable to show you the color red. So whenever we will run this program in the Eclipse, I will explain you more easily so that you will be finding out the actual color representation of the applet. Okay, so output is here. Applet state is given over here. Applet started like this. Then the method stop and destroy are not overridden because they are not needed by this simple applet. Okay, so those are not required. So as I have told you in the first session of this chapter, only the methods those are required by applet, those will be overridden. All are not compulsory. Okay, but to start, init and start maybe and paint, most of the times 3 are compulsory or more generally called or overridden. Otherwise, stop and destroy are not more commonly used in all the applets. Okay, so it is dependent upon you, like when you will call this methods or override these methods. Requesting repainting. Applet writes to its window only when update or paint is called by AWT. Okay, this raises an interesting question. How can the applet itself cause the window to be updated every time the information is changing? Okay, if the new information is coming or new information is updated, how it will be called? It will call itself. For example, an applet is displaying a moving banner. That mechanism, what mechanism does the applet use to update the window each time the banner scrolls? So answer is update or paint method. Okay, one of the fundamental architecture constraints imposed on an applet is that it must quickly return control to the runtime system. Okay, so it should return the control to runtime system. It cannot create a loop inside paint that repeatedly scrolls the banner like for loop, and this would prevent control from passing back to AWT. so that it may seem that output to your applets window will be difficult at best. And it is not difficult, fortunately. Whenever your applet needs to update, it simply calls the repaint method. Okay, so you cannot call the paint method in for loop. Instead of, you call the repaint method. Repaint method is defined by the AWT class. It causes the AWT runtime system to execute a call to your applet's update method, which in its default implementation calls paint. Okay. For another part of your applet to output to its window, simply store the output and then call the repaint method. The AWT will then execute a call to paint which can display the stored information. Okay. For example, if a part of your applet needs to output a string, it can store this string in a string variable and then call repaint method. Okay. Another part of your applet, like your banner is scrolling. Okay, so half of the banner is displayed on the applet and half of the banner is the downside of the applet. Okay, so it should be scrolled. So what you have to do is you should store the output and then call the repaint. So repaint will call the paint. AWT will then execute call to paint internally, and then your stored information like a half of the banner will be displayed. Okay, if part of your applet needs to output a string, it can store this string in a string variable and then call the repaint, and inside paint you will output the string using drawstring automatically. You don't have to worry about it. Repaint has 4 forms. First is like 4 structures, 4 syntaxes of repaint as we will see. First is default function repaint. This version causes entire window to be repainted. Following version specifies the region, left, top, width, height will be repainted. Okay. Coordinates of upper left corner of the region are specified by left top, and width height of the region are passed in width and height. So starting from left and top, width and height region, complete region will be calculated and it will be updated or repainted. These dimensions are specified in pixels. You have time, you save time by specifying a region to repaint, because instead of repainting entire applet, you are repainting only a part of it. Okay. Window updates are costly in terms of time, because time complexity you have to reduce so that you can be a better programmer. If you need to update only a small portion, it is more efficient to repaint only that region. For that purpose, that repaint method syntax is very much efficient for us. Calling repaint is essentially request that your applet will be repainted sometime soon. Okay. However, if your system is slow or busy, update might not be called immediately. You have to wait. Okay. Your system, your program will call the repaint or paint method internally, but it is not compulsory that it will be as soon as you call the method repaint, it will be repainted quickly. It is not necessary. Okay, it may be the case that it may take time. Multiple requests for repainting that occur within a short time can be collapsed by AWT in a manner such that update is only called sporadically. Okay. So if you are you are again and again requesting for repainting, that all the requests will be collapsed or averaged, and AWT will show you that update is called only once. Okay, only sometimes. This can be a problem, including animation in which consistent update time is necessary. Okay. One solution to this problem is repaint with the following structure. First is long maximum delay, and second is long maximum delay xy coordinate width and height. Here max delay specifies the maximum number of milliseconds that can elapse before update is called. So you will not call again and again the same repaint method. Like in animation. What is animation? Multiple pictures which has moving formats. Like one boy is walking from one point to another point. Say x coordinate 10, 2x coordinate 100. It is moving. Okay, from 10 to 100 it is walking. So if you want to show the animation like he is actually walking, what you will do, you will call the repaint again, so that moving boy will be shown and it will feel like it is actually walking. So there are multiple pictures at your side, like if suppose there are 50 to 100 pictures you have, that he is walking and he has come at the location 20, then he has come at the location 30, or only moving, that his right leg is at front and then left leg is at back, and again after some time back left leg is at front and right leg is at back. Like these pictures you are having and you want to show the animation. But if you are calling the repaint again and again quickly, your animation will not feel to like your boy is walking actually. For that purpose, this repaint method is provided, which has the maximum delay, which has the maximum number of milliseconds that can elapse before update is called. Be aware though, if the time elapses before update can be called, it will not be called. Okay, there is no return value or exception is thrown, so you must be careful so that your maximum time should be as minimum as possible. Okay, it is possible for a method other than paint or update to output an applet window. You must obtain a graphics context for this by calling get graphics context defined by component class, and then use this context to output to the window. So what is the option for paint and update? Graphics context object, and which you will get using the get graphics method. For most applications, it is better and easier to call through paint and to call repaint again and again. Next is simple banner applet. To demonstrate repaint, a simple banner we have developed, and this applet scrolls a message from right to left across the applet window. Since the scrolling is repetitive task, it is performed by a separate thread created by the applet when it is initialized. Okay, so when scrolling is required, we have to create another thread to handle this, as I have explained in the previous session only. The banner applet is here. Simple banner is its name. It extends applet, implements runnable, a simple moving banner. Thread T is equal to null, state, boolean, stop flag. Okay, so three things are there. Simple moving banner, T is null, the second thread object we are creating instead of main thread, then state. Okay, since it is implementing runnable, the complete simple banner is the main thread and this T is the second thread. Okay, and stop flag, true or false, we will set color. Set color, background color can, foreground color red, start thread, then new thread will be start, stop flag is false, and T dot start. So after T dot start, in run method character ch is created and thread will be sleep for 250 milliseconds, and message dot character at 0 will be displayed. Okay, so character at 0 is space, then message dot substring 1 comma message dot length. So actual message is starting with A here to length here. Okay, a simple moving banner. So this is my actual message and this will be appended like this. So every character will be displayed like a simple moving banner in a moving state. If stop flag is equal to true, then break and catch the exception. Stop or pause the banner, stop flag true, T is equal to null, so that moving will be stopped over there. Then paint method, draw string, and you will provide the coordinate from which coordinate it will be displayed, and then it will be called through repaint to move. Okay, so simple moving banner, a simple moving banner. So you will be displaying this. We will be viewing this example when we will see a practical part. Okay, so this way we have seen some interesting topics, interactive topics related to the applet class. Okay. So in the next session, we will see and try to cover the remaining applet chapter, and after that we will start with the practical one. And here I can guarantee you that the practical part will be more interesting than the theory part, because it will be more interactive and you will be understanding the applet class better. So meet you in the next session with new topics. Till then, enjoy applet programming. Meet you in the next session. Thank you so much.